Hey guys, welcome back to another video by Toe Academy, fierce competitors in YouTube education to Khan Academy. So it's understood from DC circuits that capacitors and inductors provide some resistance to the flow of current in a circuit, but what's their behavior like in an alternating current? In today's video, we explore reactance, which is the resistance of inductors and capacitors in AC circuits. So firstly, let's start with inductors. Inductive reactance, XL, is calculated by the product of angular frequency omega and inductance, L. Capacitive reactance is calculated by 1 over the product of angular frequency and capacitance. From these equations, we can see that increasing frequency increases reactance in inductors and decreases reactance in capacitors. We can think of an inductor like a water wheel being accelerated by a current of water. The more time passes, the more speed the water wheel gains, and the less it opposes the flow of current. But what happens when we continually reverse the flow of current? The wheel has less time to build up momentum and speed, meaning that it provides more opposition to this current of water. Therefore, reactance is increased. Increasing the inductance can simply be thought of as increasing the size of the water wheel. Now, everything that's applied to inductors applies to capacitors at the opposite, the main difference being that capacitors store charge instead of current. Voltage and current in AC circuits are represented graphically using sine waves because of their alternating nature. The delayed increase in current for inductors that we discussed earlier causes a phase shift in its sinusoidal waveform. We can see that it reaches its peak value at precisely 90 degrees after voltage. We refer to this as the current lagging the voltage by 90 degrees. So keeping consistent, the same is true for capacitors, but the opposite, where the current now leads the voltage by 90 degrees. Resistors are easy to work with because, as you can see, the current and the voltage are both in phase. Now that we understand reactance, we can calculate the total resistance in an AC circuit, which is called the impedance, otherwise denoted as Z. It's a complex equation where any resistance, the real part, is added to the inductance minus the capacitance, which is the imaginary part. In electronics, inductors can be used to choke out and effectively filter high-frequency noise while allowing low-frequency current to pass. Capacitors can be used to store energy and to protect components in a circuit from damage by smoothing out large voltage fluctuations. So I hope now that you have a good understanding of reactance in AC circuits, and I'll see you here for the next video.